Okay, I have redrawn our triangle. I've drawn another triangle. I filled in our answers. I've shown how we got the answers. So we left off with needing to know IT. Again, I just applied Pythagorean theorem. IT equals 4 squared, which was our resistor component, plus our 0.492 squared, which was IX, a result of IXC and IXL. Square rooted those, we get our IT 4.03 amps. So we can see our VA portion of our circuit compared to our power portion of our circuit are very close together, which is ideal. That's what we want, which means we are wasting, in this case, next to no power we're wasting. So I also drew a little reminder, Ohm's law, but I drew the P equals E times I. So I've kind of drawn it funny there. I have P, VA, and VARs in the top half of that formula circle. E, in this case, it's going to be 120 volts. It doesn't change. It's a parallel circuit. And then our I will correspond with either the P or was it the I, which was for VA or for VARs. Okay? So, given that information, if I do E times I and it was the power portion, then that's the watts I'm calculating. If I do E times I and it was the I of the VARs, then those are the VARs I'm calculating. If I do E times I and that was the VA portion, then that's going to be my total current. So I've color-coded that circle so that it maybe kind of helps you understand where I got my numbers or why I'm using those numbers. But the numbers have to be grouped. They have to stay with their groups. So we got the current for the VARs, the current for the power, and the current for the VA. And then I apply the voltage, which is the same because it's parallel to each sets of current to get either the power in watts, the VA, or the VARs. So you can see that for purple, I did 120 times 4. I got 480 watts. VA, same voltage, 120 times the IT, which was 4.03, gave me my total VA. For my VARs, I did 120 volts times 0.492 amps because that's what I got from IX. VARs is equal to 59.04. So now I can plug in those answers for B, C, and D. E was previous. That leaves me with only needing A, the power factor. So in this case, I decided to take 480 watts divided by 483.6 VA. I get 0.99 or 99%. So about as good as you're going to do without actually being unity power. So take your time, rewatch the video, pause it, whatever you need to do. I'm now going to leave, I believe there's maybe 4 or 5 questions remaining for handout 3. I'm going to let you use questions 1 and 2 that we've done now in videos as a reference. See if you can't get through the rest. Again, any questions, please put them in the discussion board so that everybody can see what everybody's asking. You can leave it as anonymous, which is perfectly fine. And then as long as the thread's appropriate, I approve it. And I'll apply or I'll answer you in the discussion board so everybody can see my answer. Again, if nothing else, we'll update some more stuff next week. Stay safe. If you're working, great job. Let's just keep rolling.